Hi, everyone. I realize we have the post-lunch time slot, so there will still be people filtering in, but we want to make sure we have plenty of time for questions with our two amazing guests from overseas. So, I'm very glad to introduce this panel. We've titled Creating the Market for Networked Heat Pumps in Europe. Doesn't matter what you call them, they're the same thing. And I'm going to ask Tamsin Lishman, the CEO of Kensa, and Cindy Demichel, the CEO of Celsius Energy, to introduce themselves, because I cannot do justice to all they are doing to transform not just the built reality in France and England, but also the story, which is happening in parallel to us over here. So I think it's a great opportunity. We're really excited to have both of them. And we're going to do presentations and then Q&A. And so we're going to try to leave a lot of time for Q&A so we can get a good conversation going. So I'm going to just step off here, take my little name. There we go. And introduce Tamsin first. Thank you.
Thank you, and what a privilege to be here. Hold on. Pass test one. I'm going to share a little bit about Kensa. And these are some what we call social housing, public housing retrofits we did last year. And I'll share a couple more of our stories as I do this. So Kensa's been in ground source heat pumps for 25 years, not because it's the easy thing to do, but because it's the right thing to do. Why is it the right thing to do? Because it's the most efficient form of heating and cooling. And what does that mean? Lowest bills to people in their homes and lowest impact on the grid. And by staying in ground source, Kensa's then developed a fully integrated customer offer. So we design, we manufacture, we install, we service and maintain, and we fund as a utility model. And we see that as really important about making the customer experience as easy for the person to switch, taking away the complexity and giving people comfort in the home. And I think in all of this, we have to sort of say it has to also be affordable to people. We have a lot of focus at the moment in the UK about energy security and energy affordability, people who can't heat and heat their homes. So this is what we've done. And again, with that, the utility model of taking away the upfront capital cost, the Achilles heel of ground source is the upfront capital cost. So 25 years. Just over 10 years ago, we moved from doing individual project homes by home, we still do that, but to doing it at scale, so doing thermal energy networks. And you can see some of our track record here, but we've done a huge amount of public housing retrofit, replacing the full energy system, taking out gas boilers and electric heating and putting in ground source heat pumps. One of our heat pumps is called the shoebox. It's the size of a it's the size of a microwave. It goes in a kitchen cupboard and allows us to decarbonize flats and small homes. And we see that as really important. And again, we design so that people have the same experience. It looks and feels like what they've got today. So for us in the UK, people heat their homes with hydronic systems. Our heat pumps do hot water and heating exactly like a gas boiler. And we want to match. We see that's really important for the customer journey. It looks and feels like how I heat my home today. And we do a lot of new build projects as well, and I'll talk a bit more about that. And tower blocks, we should do a little kind of translate, shouldn't we? Those are high rises. So where do we see the most, where we see thermal energy networks playing a critical role in street by street, block by block decarbonization is in what is, they're called the hard to decarbonize. About nearly 50% of people in Europe live in one of these areas, which is flats and small townhouses, where air source heat pumps either are difficult to install or can't be installed, and the economics of high temperature district heating don't work. So a massive kind of part of the energy transition, the heat transition, we need to solve. And also in Europe, we're seeing a lot more, even in the kind of northern climes like the UK, a lot more focus now on cooling as well as the planet heats, and we're seeing that. So the benefit of thermal energy networks with heating and cooling really coming to the fore. So, I mean, this is, you can see there our shoebox in the cupboard. And here what we, you know, our model is putting in the infrastructure in the ground, funded by infrastructure money, typically pension fund money. There, you know, we see billions of pounds, billions of dollars ready to deploy in these infrastructure solutions. People then connect and pay a standing charge, so the same model we pay for utilities in the UK today, and then a small heating and cooling box in a cupboard exactly like you have today. I think, you know, we talked about this, but we see that importance of the end-to-end solution, making it simple for people, taking away the complexity and giving that comfort to customers. And I want to share some of our stories. So this is a project, so probably I'm not the only person where people say you can't put a heat pump in every building. And I have to remind our team that, you know, our day job is putting a heat pump in all the buildings people say aren't possible. So this is one of them. This is bang smack in the center of London. Public housing owned by Clarion, so it's sort of a legacy project, built in 1913, and we've gone in, not much land around it, put in place 29 boreholes, small heat pumps in 81 flats, and now, you know, those residents are going to have lower bills and more comfort through what we've done. So a kind of, you know, for us, a landmark project about all the things people say you can't do, you know, you can do. And for anyone who's a European heat geek, Jan Rausenaar, kind of the god of heat and decarbonisation. We also, in 2023, finished our, we call it Heat the Street. So this is a street-by-street project in Cornwall where we've gone in, put boreholes and pipes in the public road and connected that to people's homes. 5 times oversubscribed. We took out oil boilers, air source heat pumps, you know, direct electric, a whole bunch of stuff. And this is now, you know, as I say, European Lighthouse Project of the Year. We charge a standing charge, and at the moment we're running at 99% on-time payment. So it shows that people will pay for access to the most efficient and best form of heating. And again, this, you know, we can drill this in the public road. And in the UK, legislation's coming in to give us the same kind of rights as water, gas, electricity, and other utilities. And then I wanted to finish on the thing that I think, you know, probably excites me most about what we're doing. So coming into force in the UK, new houses will not be able to have gas boilers. And we have a partnership with a company who do currently install half the gas pipes, gas connections to new homes. So their incentive is they need to find a replacement business model, and ours is they're an amazing route to market. And we've co-developed an offer that's cheaper for the house developer, which is good news for house developers. Cheaper for the inhabitant of those homes because of the efficiency of ground source, can provide effectively free cooling, which is a real plus in Britain. And the sort of the killer of it all is because of the efficiency of ground source and the use of thermal energy networks that allow diversification factors, we can offer to the new build developer that they can roll out their development without needing to upgrade the grid connection. So they can build out as if on gas from the electricity, giving them speed of build out and lower costs. And I think for me, that's the sort of bit in this about, you know, the innovation and the commercial business models that will come as we scale, and that we can have it all around lower costs to people, not having to break the grid with thermal energy networks. Thank you.
Thank you, Tamsin, and thank you all for welcoming me and having the opportunity to be in that panel, and actually to meet also Tamsin that we haven't been able to meet in Europe, so we have to come here to meet, so that's cool. really cool. So how do we open heat pump, ground source heat pump market over in Europe? So I'm Cindy de Michel. I'm the CEO of Celsius Energy and co-founder, and we operate in France. You can hear the accent. In the UK, and actually here, and you've been having a presentation on the Eversource program in Framingham that we worked in with the team here. So, well, starting with the basics, the reason why we do things is actually that 50% of the world energy is actually used in the form of heat, right? And that heat is mainly provided through fossil fuels right now, emitting a lot of emission, CO2 and so on. So of course this is the problem. This is the why, and the other why, and maybe this is a bit specific to the to Europe. In Europe, we do not have AC everywhere, not like here. And as heat waves are coming, are more frequent, longer, and even going to higher temperature. Heat waves sometimes like, heat waves. I'm just gonna enjoy myself in the under the Eiffel Tower, where heat waves is actually not this. Heat waves prevents people from working. It gets people trapped in their housings with no AC. I mean, this is a real problem, public problems, health problem, and an economic problem. So more and more we need that. So heating and cooling, well, there is a solution. You guys are here, so you know the solutions. So please spread the word. Geoenergy or ground source heat pump. So 70% of the energy that the building needs is actually sitting under its foundation. So let's just get it. So what we do in Celsius Energy is we design and we we execute jobs and install those type of installations. And actually we also perform, monitor and optimize performance after the fact, which is good. And so we digitally assist operation and maintenance. So the solutions that we implemented and we developed is to be simple, to be renewable, of course, and scalable. And this is where it's going to come. So optimized design, you might have seen already, this small footprints actually are reducing by a factor of 100 the footprint that you need to make those type of installations. So really going for a star shape. That means that actually all of a sudden the retrofit is possible. And of course, 90 or 95% of the building of 2050 are already there, so we need to find solutions so that we can address them, right? So we optimize the design, develop solutions to reduce the number of wells as well. When you replace gas by ground source heat pump, you know that already. We have all kinds of experts here. We divide by 4 the energy that the building consumes. And by up to 10, depending on the carbon content of your electricity, the emissions that you will be providing. And with the digital performance, once it's installed and you've been reducing the capex, optimizing the capex, then you leave it to the utilities, usually our gas providers, to perform it. And we also have performance system that would allow you to get another 20-30% OPEX optimization afterwards, right? It's really to get the data and work on the optimization of performance. Scalable, we are to the point. It's possible to do this kind of things at a building scale, but also larger scales, multiple buildings or even neighborhoods. And this is also what we do. So this is the reason why we are here. Like the Framingham project you had here, but we also have some others across Europe. Getting this star shape also enables to do this type of installations in places where you have existing building and dense urban density. In Framingham, if I take this example, one of the place where a borehole exchanger was to be drilled is a parking lot of a school. If you look at the parking lot, it's cool because you have rooms, so you could fit the vertical wells. However, when we started drilling, the school guys were coming, oh, I need a parking lot. I really do need that because the parents and this and that. And okay, don't worry, we're gonna just be at the end of the parking lot and doing our incline drilling. So that's an enabler. Not saying it's not possible as well, but it's definitely an enabler. Um, I've talked about that. This is really not just doing the thing, installing it and disappear, but actually helping the utilities to monitor the performance and optimize it after the fact. And really you can gain another part. It's not I design, I build, and I disappear. It's I design, I build, and I help performance afterwards. Just a few examples here at the scale of a building, indeed, but also thermal energy networks, and those are examples. We have examples of a huge social housings in this one, in full neighborhood. So that's the Framingham, but that's also a 4 million square feet project we have in France. It's the largest project ever in Europe, largest borehole exchanger, and some other project really saying that this is possible everywhere: commercial buildings, public buildings, little one on historical buildings that we have everywhere. I guess some of your universities as well, where you don't want to destroy the old walls and get some patrimonial as well buildings. Industrial campuses, a lot on them. Actually, the industries, they're very pragmatic, so they can say yes or no very quickly. So that's something that we love, right? And education as well. So that's just some of our project, and I think I don't want to take too long, because the interesting part is really about conversation. And maybe a little bit before the conversation, how do we do that? There is, of course, the industrial solution, developing it, and etc. But at the end of the day, this is what we're all doing here. We need to be all together to raise the awareness. And this is an example. We created the France Geoenergy. So this is a community collectively raising these opportunities. And that covers the whole value chain of the building industry, from the professionals, as most of us maybe are, but also the users and the manufacturers and the energy utility people, so that we all take the same message and go. And that ended up, we created this in 2022. It was also, you can see this is the energy ministry here that came, that afterwards deployed a national plan on geothermal, including ground source heat pump, and bringing that topic as well to European Union, just to raise the topic. We're all there for that, and this is one of the things that we do as well. Zainab, the floor is yours.
Thank you so much, both of you, and I'm sure you're all very excited to ask questions about the details of what's happening. Oh, thank you. The good news is I left my phone up here to keep track of time, so I am going to take moderator's privileges and ask one question to each of you, and then I have one last question, but in between there's plenty of time. So my first question for you, Tamsin. I first met with Kensa in, I think, 2019, and then was just overjoyed to see the announcement in the Glasgow COP of Heat the Streets. And I just would love to know a little bit more about what you learned from that process of drilling in the streets, and where you see it in terms of growth.
Okay, so I mean, this was the street by street, block by block retrofit we did. I mean, what would I say about drilling in the street? Like, people do this every day. People dig holes in the street every day. It's kind of what, I mean, I don't want to underplay it, but it's sort of, there's nothing very special about it. I think and very similar to Eversource, part of the talent of what we do is really strong, engagement with those people in their homes. Actually, in many of our projects, because people's bills go down, we see people that are desperate to be the next one in the queue, because they've seen their friend or their neighbor's bills go down. So they're chasing us to be the next one in the queue. And that's the kind of thing that makes a difference. And that care about it looks and feels like what you've got today. So I'd love to say it was like, it's, what would I say? It's essential we get the same rights as other utilities so that we can drill in the street. Our model involves drilling roughly every second car parking space. it's the first 2 meters, which are standard digging practices, and then after that it's just ground. And then the critical thing of that, resident liaison, customer engagement.
Thank you. That's very encouraging. And Cindy, I've actually just recently been reading about the French geothermal roadmap. And I'm getting a little bit jealous. You have, as I heard, a national investment in drills and drilling workforce, and I was hoping you could tell us more about the roadmap and the process.
Well, so there is indeed there was a roadmap and a plan looking for how much geothermal and ground source heat pump could actually provide as energy, and maybe one magic number was 100 terawatt an hour, and I'm not gonna translate that into imperials unit. I'm sorry, but this number is actually the potential of geothermal and ground source heat pump. Actually, ground source heat pump to the potential number that you would actually the potential for France to provide geothermal heating and cooling. And actually, this number is exactly the 100 terawatts an hour is exactly the energy that we import from Russia, the gas from Russia. This is so basically what that plan says is if we develop a ground source heat pump in France, you could replace the Russian gas by this, right? So that's really the ambition. And now about the drilling part, so there is a lot of actions in that plan, and the drillers. So, and I've heard it in many of the side discussion we had since yesterday. We're missing drillers. We're missing drillers. When we're missing drillers, so we need drillers. We need drillers, and we need drillers. That's simple tripling solution. And indeed, so there was some initiative about putting together schools and also converting the workforce into drillers. This is not an easy job, so that need to be recognized, to be paid at the right level, and you also need to get a good technology training, formation, and etc. So that's something that is ongoing in France, and that and I know you have also some initiatives right here. So I think we're pretty aligned, and I look forward to be jealous of the USA, and with the IRA you were already good. Let's see how it goes in the few weeks.
See, that's good competition. I think the issues, the more I learn every time, the issues are so much the same with the exception of the measurements units. So I want to make sure there's lots of time for conversation and questions. So I'm going to turn over, and then just right at the end, I have one last question. So first questions.
Cindy, this is Max Shavako, John Shavako's son. I have a question. I saw on your slides that it said you had AI predictive maintenance. Can you elaborate on that a little bit?
So basically, when we install a solution, usually we would put some sensors to collect data from the boreholes, but as well from what's happening in the technical room, the heat pumps, and even the secondary circuit, for instance. And then we will collect all of this, and basically we have some algorithm that would, in case we do the whole thing, we don't have to do the whole thing every time, but if we do it systematically, then you would learn from the usage, and you can actually learn from the usage of the building and make sure that you couple the underground capacity with the building demand, and this in a real time, so that you can actually predict what you will be needed because of the meteo, because of the usage, because of blah blah blah, and use that battery, the thermal battery, when you need it. And so that will also help the operators to actually know if things are drifting, and if there is some predictive maintenance to be done before it actually fails. But it's not just failing; it's also optimizing.
Yeah, and I think we see the importance of both predictive maintenance, but also smart controls and the ability to connect to low time of when the electricity is cheap, so we've got flexible electricity pricing, and also being able to bid into things around when you can bid into value from the grid capacity. So there's a whole set of other value stacks that we can play into using smart controls as well. Really important source of value.
Great.
Rebouncing on that, coming back to you, the grid part in the UK, you already have flexible prices, right, and electricity cost, which might not be yet there in France, or to some extent, but this is definitely the world of energy that we are evolving in. So we will need that to be predictive indeed.
So I know the next question's right there in the back. Oh, wait, we've got mics. Oh, so sorry. Yeah.
Hi.
All right, Max.
Hi, everyone. Yeah, thanks so much. Great presentations. So one of the inhibitors on a lot of projects is first cost, capital costs. And I noticed, Tamsin, on one of your slides, you mentioned that you made an agreement with somebody where geothermal was competitive with first cost. I'm curious what it was that got you to that point.
Yeah, so we see it as really important to be able to take away that upfront capital cost. So part of our business model is a funding stream to take away that capital cost and then charging a standing charge. In our partnership in new build, it's a heat as a service model. So basically the whole capital cost is taken away and the people in those homes pay a standing charge. Now, we're seeing that's just through our partnership of deploying something like £300 million of infrastructure costs every year just in new build and just in the UK. So you can see the potential. And again, what it is it's boring pipe in the ground with index-linked returns, which is kind of, nirvana for infrastructure investors. So that's it. I mean, that's a choice on our agreements. I think it's over 25 years with the option to extend for 40 years. But the ground infrastructure will last for 100 years. So that's just, an investment choice.
Hang on.
Wait.
Can we just have all questions go into the microphones, please? That's where we're recording.
Gino DiRezzi from Ground Heat in Canada. We understand that we see that Celsius is an oil and gas company based, and now they're going to need geothermal. Can you tell me more about that? And also the patent for angle drilling by accident or by mistake have always been done. And there's a patent, and can we not drill angle now because of the patent? Thank you.
So maybe I'll take the second one first. When we first did the incline drilling, we're like, okay, let's try to do two things. The first is a vertical traditional way, and that was with the French drillers in Europe. And the second with our incline drilling and specific technology. And actually, so we were like, okay, this incline should be that trajectory, azimuth and orientation and etc. and should fall here after 200 meters, 600 feet, this conversion I have. And actually we drilled our angled, and it was, after the 200 meters, 2 vertical depths, you get maybe 2 meters apart, which was less than 5% deviation, because we used specific trajectory, right? And this was measured. When we drilled the vertical way, traditional way, the vertical way went that way and 70 meters from his original plan, which we do not measure, right? So not saying it depends on geology, depends on many things, right? So this is angle drilling, not by accident. This is on purpose, and we measure the thing after the fact as well. Now coming to your first question, I've seen indeed there is lots of people here that are coming from other industries, and especially the oil and gas industries. So Celsius Energy is a subsidiary of SRB, ex-Schlumberger. So I've been myself and my 2 other co-founders in SRB for the past X years, not saying. So entering as blue babies, and and actually after 10 years, 12 years, we were like, and this is really, I mean, that was a coffee machine discussion where we were like, okay, there's a lot of know-how, technology, drilling, digital, a lot of things in our toolbox, and there is this huge challenge about climate change. What is it that we can do to connect both? And that really was our the why of the three of us co-founder, to really climb the stairs to up to the CEO level and to say we want to do something and we have this idea. And actually, for the little record, when I went to the CEO and saying, CEO of SLB saying, oh, I'm gonna do ground source heat pump and drill the 200 meters, 600 feet, I was like, I got, this is not drilling, Cindy, this is gardening. Yeah, right. But there is a lot of garden, and I like the flowers. So we managed to convince the oil company, and actually, I mean, this is the trend, right? Those companies have to go through diversification and etc. They build a new energy with a large portfolio. We're part of it, and we're really we're really proud that those companies also are listening to those type of ideas and giving a chance.
Just a follow-up to Tim's question, what's the average residential customer charge when you amortize this over 25 or 40 years?
Oh my goodness, I can't remember. I'm looking at my colleague. I mean, I'll talk about, so our goal, so today if we went into a classic, just a normal street, it would cost more than gas today in the UK. So there are particular, things where we can use waste heat from sewage or offices or data center that help the economics, things where, but it's to get it to be no more expensive than gas. I think that's a standing charge of around £4 a month is what we're aiming for. Now, we're not there at the moment, but that's our goal. And through scaling in new build and retrofitting public housing, we see a pathway to get there.
Did you say £4 a month?
Sorry, 20 a month. 20
Okay.
a month.
Okay.
No, £4, yeah.
Thank you.
Who wants it?
So what are the barriers to deploying here in that same manner?
So I don't know the barriers to deploying, fully here. I can say what our barriers are. So our number one barrier is always awareness. What people are used to is what they've got. So kind of the sort of, status quo. The lack of awareness of solutions like this. People know about air source heat pumps and they know about high temperature district heating. So number one barrier, awareness. And then number two barrier, the adoption of a different way of heating, sort of just inertia, I think.
And maybe to continue on this one, I've heard a story about the CEO of a real estate developer. They are operating malls, and he told me a story when he heard about the geothermal ground source heat pump. He told me, I wish I knew that a few years back, because he got this mall, Connecticut, and it was an aging mall, and he needed to get a more, restaurant and more shops and etc. And actually, the gas provider told him, this is a nice project, but I don't have that amount of gas to provide to you, so forget your project. It's not gonna happen. And the guy has to sell his mall to get rid of his asset. And because no gas and air source heat pump for some reason didn't work, maybe the climate too cold and etc. And now it's really interesting in looking at those type of solutions to get resiliency and be able to control that amount of energy that it needs. We can see that the people is actually used to that configuration. They're all to the screen.
Yes. Yes, everyone's on the screen so they can see you. I'm gonna shift slightly and ask a question both to our panelists and to the audience. because what I was most excited about with this particular panel and conversation is that what I keep seeing as I learn more is that there are really similar challenges and opportunities across the pond, and that the US and the EU are both in the same extraordinary situation as I know you've felt in the energy in this conference and the growth, that we have this incredible growth trajectory ahead of us, maybe, if we pull it off, right? And it's not actually that easy. We're at a challenging point. And I think the same is true, and we kind of can see the writing on the wall in Europe and the US. And so in that moment when we have numbers of, for example, ambient temperature loops we can count with our fingers, widening the circle and looking at the technology across both the US and Europe actually jumps us ahead and changes the conversation and de-risks it for the decision makers. And so my question is, within the context of the news that the Energy Information Administration, the EIA, which we've probably all downloaded little charts from, is for the very first time in history writing a geothermal report. Now, admittedly, a lot of it is that deep geo, but the heat pumps in there, the geothermal heat pumps in there, it's coming out at the end of November. So my question is, what should be in that report to drive the change and de-risk what we need? Like, what do you both want to see in that report? And then kind of turning the question to the audience, what do you think is critical that we could join forces on?
So I think I talked before about the importance of awareness. So, for me it is that this is a recognized mainstream solution. And, there's just a set of things that we need to have in place, and we probably talked about it. So, you need the supply chain. Most of the supply chain's abundantly there. We're going to need to invest in drilling capabilities. We need the rights to be able to do work in the street like any other utility. And we need the business models that will bring in private capital to fund the infrastructure solutions. And otherwise, it's kind of then just let us get on and make it happen. It's not that difficult, but that kind of, here's the playbook we need, and making it show that it's, it is a mainstream, abundantly available energy solution. And also then the positive impact on the electricity grid. And, and then being able to feed that into the city scale planning as well.
Yeah, I think the part on electricity grid and the flexibility that we will all need is something that is not taken into account right now. We've heard this morning there was a Northwell Health talking about hospital and how he started getting the low voltage coming to his hospital, and he doesn't have any redundancy and emergency system to get more of electricity. So indeed, using that battery, really understanding that this is a battery, a thermal battery we have under every building, is goes with awareness. In Europe, we also have the Fit for 55, so a bunch of directions that are on the table. And that are also, we talk about carbon tax, carbon regulation, and etc. And the building industry is still lagging behind somehow. 26, 27, this should come, hopefully, cross fingers, things can change, for the building industry. So that the price of carbon is not just a tax. Actually, it's the price of carbon. It's actually the price of getting those heat waves, those people, the floodings, and blah blah blah. Right. So that's also something that people can do now in our level. Well, this is what we do, all of us, right? Bringing awareness and conservatism, I would say, in the building industry is also something that. Should all work for. I install a gas boiler because I've always done that, and so on. So that's also something it's hard. It takes time, but then I can turn the question to you, Zainab, and everything you do with all the municipalities and etc. How do you change their mindset?
Oh, that
We're
wasn't
not
supposed to
ready for
happen.
that.
I'm the moderator. Thanks, Cindy. Gosh, I don't have an answer. I think that you actually already have both said the answer, which is education and building a large network of people and different stakeholders and having the time for those conversations, the back and forth, learning, listening, responding, and that gets us to de-risk change. Because someone once said to me that humans actually don't hate change, they just hate risk. And so if you de-risk things through knowledge, through conversation, through examples, through hearing that they're doing it in Europe too, you can actually move a lot of different stakeholders at different levels forward. And people are pretty excited, right? So here we are networking people to network buildings. And I love that you guys have met for the first time here in New York. So we're bringing, England and France together. Here we go. But I want to turn it back to all of you, and I'm really curious. The list that Tamsin and Cindy just shared of what they would love to see in that report, which will be this pulse or signal from like the central, energy administration data source, that geothermal is not in the other category. It actually has its own report with its name on it. Are those the same list? Which ones rang true, and what do you think needs to be there? What do we need here in the US to realize the potential we have? Oh,
Come on, don't be shy.
Yeah. Donovan? He's checking his head. Come on.
Did I see a hand?
Oh, we've got microphone over there.
Cost data, a lot more cost data, so we could build the business models for it.
Yeah, I think mine's piggyback onto that it's the cost, but also the value data piece to it. It feels like there's so many different value streams, but they're a little disparate. And so if there's a way to bring that all together and to show how overwhelmingly positive it is to put in these systems, and then when we layer that over the cost data, it makes more of a compelling story. But we don't have that in one nice, convenient spot right now.
Hello, Richard from Kensa, one of Tamsin's colleagues. And it's an interesting point on the cost down, because when we started installing heat pumps, we were doing it on an individual property basis, and we discovered pretty quickly that you can't be competitive with air source on an individual property basis. So we've moved into the large scale developments, and I think Kensa's done a lot of work on recognizing that the property by property costs are a lot more competitive when you've mobilized a drill rig to do a whole development. And we need other people now to come out, and in the US with comparable and supporting data to sit alongside that even if you put on that amortization cost, because of the higher efficiencies of ground source heat pump versus an air source heat pump, the running costs are still lower from the work that we've done, and you've brought down the upfront cost to being level. And then it has those added benefits of reduction in grid upgrades that are needed. So I think there needs to be more common views from around the industry that sort of supports Kensa's view there, and stuff like that being featured in the IEA report to support it as well.
So, and just to build on that, making sure we get thermal energy networks. So in Europe and the UK, there's a lot of work going on about city scale heat and cooling modeling to find the best solutions, making sure we get thermal energy networks into those models.
So if, following that, if one borehole can give you 4 or 5 tons per home, you can scale that every front yard, you can have one borehole into the house. It can heat and cool the building forever. So this is the scaling you're talking about. And it could be in easements that have with utilities you mentioned. With regards to the other question, the geothermal has been invented a long time ago. The late 40s, mid 40s. Tests all over Sweden, Northern Europe has really done a big job of it. If on the report you can reassure that there's been the last 40 years, 45 years, at least my lifetime anyways, that I've been involved in this, there's been progressive. Nobody's got blown up by geothermal. It's been reducing energy, maybe sometimes not cost, because the fluctuation of power, the competing gas is always changed. But there is a CSA standard that we started in 1990. Was mostly for Canada, a standard for geothermal. Mostly for Canada. In the last 6-7 years, now it's also binational. So this standard gives you a way of reassuring that the installation is done right. So we just want to reassure the public that there is a system, and as time goes on, most other jurisdictions and states will adopt this standard. That basically, not to fear what's underground, so that basically you have standard that tells you the size of heat pump you need for these buildings, the size of the ground source, and there's also a safety measure this as well. So if the report shows that, you give some kind of level of comfort to the engineers and the owners, so then it'd be good.
And we totally agree on the need to have quality standards. You know, this to be a reputable business where people remain comfortable in their home. And I think we pride ourselves at Kensa on that. I know Celsius pride themselves on that. You know, and it's good to see, you know, this the sort of the ethics of the industry, and we agree about the need for standards. We voluntarily signed up for something called Heat Trust, which is like a precursor to heat regulation, but it's basically setting standards for customer service and what we do. And we think that's just very important to get that trust, confidence, and give people the knowing that they and their family are going to be warm in winter.
And even we can even say that it's not just shallow geothermal or ground source heat pump, as not heat pump, but geothermal. It's been there since the Romanian, right? Even before that, right? The caves and so on. So using that heat is very... Actually, I think the challenge right now is to show that we can move away from the niche that we are in. So building good references at scale. At scale, that means those thermal networks, but also the multiplication of commercial buildings, individual houses, all of this we really need to show we can scale. That goes with quality, that goes with safety, that goes with also big players entering the game. And we see some consolidation of players across the world, in the US, in North America, in Europe as well. So we need to really to show that this is tipping, right? There is a tipping point. It's not just, yes, I've been drilling a well at my grandma's house. We're not there anymore, right? And all, I think we all agree around that table. So bringing the references, showing that this is safe, and this is where HSE, quality, data, performance monitoring, not just saying, okay, the library of my municipality was put to geothermal 50 years ago. 3 years after, we shifted back to gas because of, we don't know really. So that goes with utility, that goes with operators being able to maintain, being skilled for maintaining this. So that goes with the whole professionalization of the industry and awareness, of course.
And I'm just going to pick up on what Holly said about there being so many benefits you almost get lost, and then what Gino said about, basically bonus, it doesn't explode. And when we are doing all of the balance sheets of, amortization and customer cost, and we know that the cost per month for energy is the lowest, so the question is that infrastructure and how do we pay it off? In none of those balance sheets, I think on either side of the Atlantic, are we putting the dollar value for the resilience of it not exploding, which has a dollar value. In none of them are we putting a dollar value for health. We aren't putting a dollar value for the electric grid impacts, which are enormous, and thanks to the DOE, we now have numbers. And so that question of how we account for all of those benefits, and I think that one is high on my list, and it's the easiest one to start with is that electric grid piece. But I'm going to pick on this side of the room because no one's talked over here, and I there we go. We've got some. Thank you.
About to make a bad joke about Romanian and Cesar asking for the micro, but I'm not gonna do that.
And sorry if this is trying to peel the onion back a little too much, but what more can you share about the financials that made the GTC partnership viable, right? Especially in the pockets of a portfolio where it's not new construction, right? And so mindful that you're at a point in the adoption curve, right, which is I think probably different than where we are, and so mindful of those challenges. But what models supported that transition?
Okay, so this is a partnership in new build. And the first thing that's really important is this is, the driver for this is an incoming piece of legislation around no more gas boilers in new build homes. So electrification of heat. So there's a policy driver. And, we need to be absolutely clear. If there wasn't a policy driver, there would be some homes that adopted it and some local, the equivalent of our states, who'd make it happen. But fundamentally, that's the driver. And then we've got a business who have really, they do half of the electricity, gas, water, and fiber connections to new build. They've got really well established, who've got an existential threat because they can no longer do gas connections. And so want to find a way of continuing to deploy Brookfield capital into a heat solution in new build. And we're a partner for that. Now, what do we get out of it? Route to market, faster scaling. And then we spend a lot of time, they really understand the needs of the house developers. What's that winning commercial offer? We want to be the best thing. We want to be the new default to gas. And so what will that take to do it? And then working through how can we create an offer that does use ground source efficiency, diversification factors to be able to say you can build out on your existing electricity connection. And then, then making the offer work. But in this, they've entered new markets in water, in fiber. They've done it before, so they're kind of following a playbook.
So we have time for one quick question, or I can ask both of our panelists a question. All right, I'm going to do that. So, assuming, of course, that you're wishing us well on this side of the ocean, what is the thing you would most hope to see here? And of course, you're here as well. I want to acknowledge that. But in terms of like a hope for the industry for North America, your number one pick, and then also for yourself in Europe.
Okay, so I think my number one pick is it becoming just an accepted standard solution. I kind of want to die a bit whenever someone suggests a pilot with us, and we're like, we don't want to do pilots, we want to do this at scale as a major solution. So I think it would be that it's just part of the heating cooling transition mix. It's just an established solution. And then with that come the business models. And I suppose I can't reinforce the importance of making sure the business model works at to scale.
Wow, yeah. Scaling, it's number one is good. Maybe openness to new design and to new business models, and indeed, I mean, maybe going back to your point, and this is true everywhere. You know, when there is a heating and cooling solution that needs to be designed for a building, then you go to any mechanical design firm, and then gas comes. Maybe Eversource heat pump comes, and Geo never shows up unless you know somebody that at some point did something, and you're not too risk adverse. But there are some engines there that are used by those design firms. So maybe just plugging a GEO option there so that it comes up to anyone that has an actual project ongoing, so that it shows up. So there might be the how or the why. So bringing to scale and maybe building the tool so that not just us know about the solution, but it actually pops up in any type of solutions with the good values that cost ownership, total cost ownership, right? It's not just cost, and carbon as well. I know that in Europe we talk a lot about carbon. In the US, we talk less about carbon, but this is also a value that needs to be faced.
And then if I had my fairy wand for us, it would be, so in the UK, there are what called local area energy plans. And in the EU, there is I can't remember the regulation, but about city scale heating and cooling plans. And it is that in those plans, thermal energy networks feature front and center as a core part.
That sounds pretty good. Thank you both. I know we're at time. I could keep going, but a rapid show of hands. Does that sound good for us here in the US? Scaling on the table? Yes. Thank you both so much.
Thank you, everyone.